Namaskar everyone. Indian Master Ji welcomes you to this YouTube channel. In this video, we are going to see another example on how Poisson distribution can be used as an approximation to binomial distribution. But before we start, a small request. After watching the video, if you find that it is useful, then please like the video. Help your friends and other students who also are in need of such useful content by sharing this video. If you are new to this channel or haven't yet subscribed to the channel, then please subscribe to the channel and press the notification bell. This will help the channel to grow and help you to know each and every time about such useful videos as and when they get uploaded on this channel. So let's begin with this today's video. The question which we have taken is from May-June 2020, paper 62, question 3. Let's read out the question. In a data entry department of a certain firm, it is known that 0.12% of the data items are entered incorrectly. So the percentage of data items entered incorrectly is 0.12%. And they are saying that these errors occur randomly and independently. Now whatever the data entry is happening, they are taking a sample of 3600 data items, and the number of data items entered incorrectly is denoted by the letter X, and they are asking for the distribution of X including the values of the parameters if any is involved. Okay, so they have already given us that X is what? X is nothing but the number of data items which are entered incorrectly. So I'll rewrite this here. A first. X is the number of items, the number of data items entered incorrectly in a random sample of what? 3600? In a random sample of 3600 items. Sample of 3600 items. Okay, so if you see here, there are 3600 independent items. Okay, and out of these 3600 independent items, the success, what is the success here? That the data is entered incorrectly. Okay, the probability of success they have given is 0.12%. So it clearly shows that X is following what? Binomial distribution. Why it is following a binomial distribution? Because there is a definite number of independent trials, that is 3600 here, and the probability of success of in each trial is 0.12%. So 0.12%, can I say it is 0.12 divided by 100? Correct? So here what is 3600? Here 3600 is nothing but my n, and the probability of success will be what? P is 0.12 divided by 100. So what will be the value? This will be 0.0012. Okay, so this answers the part 1 of part A. Then they are saying state an appropriate approximating distribution for X including the values of any parameters. Justify your choice of approximating distribution. So here if we see, n is 3600, n is 3600, which is greater than 50, correct? And if we try to find out NP, what will be NP? NP will be 3600 multiplied by 0.12 divided by 100. So if we solve this, what value we will get? We will get this as 4.32, which is less than 5. So here n is greater than 50 and NP is less than 5. So therefore can I say, therefore this binomial distribution can be approximated by Poisson distribution? It can be approximated by x, random variable x following a Poisson distribution. And what will be the parameter here? The lambda will be what? 4.32, where lambda is 4.32. Okay, so this answers the part 2 of your A part of the question. Let's go to part 3. They are saying use your approximating distribution to find probability of x greater than 2. So probability of x greater than 2 they are asking. So x greater than 2 if I have to find. So this I can say is nothing but 1 minus probability of x less than or equal to 2. Why we can say this? Because we have studied earlier also that summation of probability of x taking a value equal to r, where r value varies from 0 to infinity, okay, is always equal to 1. So that means sum of all the probabilities will be equal to 1 here. Here luckily enough r is going up to 3600 only. So I can say this is equal to what? This is equal to 1 minus probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. Correct? So I can write this as 1 minus, here for these three probabilities I can take e raised to minus lambda outside. So that means e raised to minus 4.32 outside into inside the bracket what I'll get? Lambda raised to 0 upon 0 factorial, that will give me 1. Lambda raised to 1 upon 1 factorial will give me lambda, that is 4.32. Correct? And the lambda raised to 2 upon 2 factorial, that is 4.32 ka square divided by 2 factorial. Correct? So if we solve this whole thing and I subtract it from 1, what value I get? I get a value 0.805, which is rounded off to 3 significant figures. Okay, so this ends with the part 3rd of question number A. Now let's go to question B. They are saying another large random sample of n data items is chosen. So first of all, the random sample is large, n data items is large, so n ka value is large. They are saying the probability that the sample contains no data items that are entered incorrectly is more than 0.1. Use an approximating distribution to find the largest possible value of n. So they are saying that here n is large. So if n is large and the probability of success, that is probability of the data item being entered incorrectly, is fixed. What was the fixed value? 0.12%. So here again the random variable will follow a binomial distribution, but because here n ka value is changing and we don't know the n ka value right now at present, other than that it is a large value, we will change the variable. We'll say let y be the number of data items entered incorrectly, in a random sample of n data items, Okay, so here y will follow a binomial distribution with n value as n, and the probability of success, that is probability of the data item to be incorrect, being 0.0012. Correct? Now we will have to approximate this, because I don't know the n ka value, but they are saying n is large, so we can approximate this directly. We can say that therefore y, which is following a binomial distribution, can be approximated by Poisson distribution, that is y follows Poisson distribution, okay, with the parameter what, n into p, that is 0.0012 n, okay, where lambda is in fact 0.0012 n. Why I am able to approximate this? Because n is very large here. N is very large, is large value, and p is a very small value. If you see 0.012, so we can assume that n into p is going to be less than 5 and n has to be greater than 50, as they have already said that n is large. Okay, what else they have given? They have given that probability of y equal to 0 basically is greater than 0.1. That is, there is no data entry in this large sample, okay, is greater than 1. They have given this particular probability and they are asking for the value of n. Correct? So let's try to solve this. Don't have much space here. Let's take a new page. Okay, so since they have given that probability of y is equal to 0 is greater than 0.1, so using the formula for Poisson distribution, can I say e raised to minus lambda into lambda raised to 0 upon 0 factorial? Lambda raised to 0 upon 0 factorial is greater than 0.1. Correct? So this means what? This means e raised to minus lambda is greater than 0.1. Okay, so if this is the case, because I have got an exponential term here, let me apply natural logs on both the sides. So if I apply natural logs on both the sides, so ln of e raised to minus lambda will be greater than ln of 0.1. So by the property of logarithms, this minus lambda will come down and it becomes minus lambda into ln of e is greater than ln of 0.1. But ln of e is 1, so that means minus lambda has to be greater than ln of 0.1. We also know that whenever inequality is involved and we divide or multiply by a negative number, the sign of the inequality changes. So here I am going to divide by -1, so the sign of the inequality will change. So here lambda will be what? Less than minus ln of 0.1. Correct? But what is this particular value? If we solve it on the calculator, then we get something as 2.302585 and so on. Okay, but this is lambda. But what was lambda value of us? Lambda was 0.0012 n. So can I say therefore 0.0012 n is less than 2.302585 and so on? Correct? So if I divide now both the sides by 0.0012, so what do I get? 2.302585 divided by 0.0012. So I get some particular value. What's the value? I get something as 1918.820 and so on. They are asking for the largest value of n. So here, because n is has to be less than 1918, so the largest value basically I can take is 1918, because n has to be an integer here. This is the largest value. Okay, so this ends with the part B of this particular question. With this we end this question also. Hope you have found that the video is useful. If yes, then please like the video. Help your friends and other students who also are in need of such useful content by sharing this video. If you are new to this channel or haven't yet subscribed to the channel, then please subscribe to the channel and press the notification bell. This will help the channel to grow and help you to know each and every time about such useful videos as and when they get uploaded on the channel. Comment what was good and what can be improved. And finally, till we meet in the next video, stay healthy, stay blissful. Radhe Radhe.